Okay, so we're going to talk about two different things in this lecture. And you'll find actually that they are related. So that's why I'm combining them. Also because I'm wanting to move us forward so I don't have to do this lecture in 2 days. I want to just do it in one. Properties of real numbers. There are lots of properties of real numbers. We could spend 3 classes learning properties of real numbers. But there are 3 in particular that are outrageously important for algebra that you need to understand because so much depends on your understanding of them. The first one you already know. You've already learned this first one. It's called the commutative property. And this property is true for both addition and multiplication. So it's both true for addition and also multiplication. Now I'm going to write a formula, meaning I'm not going to use numbers. I'm going to use letters that represent numbers, okay? So you just have to realize that even though they're letters, those letters could be any number. I could put any number into those letters, and it would always be true in math, okay? So here we go. We're going to try. I'm going to say an example of commutative property of addition would be A plus B equals B plus A. Right? And that means, and if that is a true property, A plus B equals B plus A. If that is a true property, it would work for any numbers that I could put in there. So let's try. Let's say A is equal to 2 and B equals 3. 2 plus 3 is equal to what? 5. All right, is equal to 3 plus 2 is equal to 5 equals 5. It works. It works, right? An example of multiplication would be A times B. And remember, in algebra, I don't have to put a times thing. When I have 2 letters next to each other, it automatically means multiply. Automatically. A times B is equal to B times A. Ab is equal to ba, right? So easy to remember. No. Now, again, this has to always work if I put a number into it. So I'm going to say A is equal to 3 and B is equal to 8. 3 times 8 is 24. And 8 times 3 is 24. It works, right? Works. Always works. Now, when does it not work? And watch this. Watch, it does not work for subtraction. So, not for subtraction. Because for subtraction, watch this. If I did A minus B is equal to B minus A. Let's try that. Let's say A is 10 and B is 4. 10 minus 4 is 6. 4 minus 10 is you get the same number, but it's the opposite, sort of, right? It's the opposite of the number. The signs are opposite, right? So it doesn't work for subtraction. But look at this. If you turn subtraction into an addition problem, it works. Watch this. If I did this, if I said instead of A minus B, I said A plus a negative B is equal to negative B plus A. Let's see if that works. 10 and 6. So 10 plus a negative 6 is, all right, negative 6 plus 10 is 4. It works when you turn it into an addition problem, right?
Algebraic addition.
Algebraic addition. So, but the main thing is for commutative property, it only works for addition and multiplication. It doesn't work for subtraction or division.
Or division.
What?
I wrote it all opposite. I said that it didn't work for
It does work for, yeah, you did it backwards. So I'm going to erase this one because this one now is really, the way it works is when it's for addition, so I don't really need this. Okay? And that makes sense, right? That was when I had Sakara and Wyatt up here, right? Sakara plus Wyatt is the same as Sakara plus Wyatt, right? Well, Sakara plus Wyatt, Sakara plus equals Wyatt plus Sakara, right? You got it, right? So that's E. And notice, to remember this, I always think of the root word, the root of the word, commute. When your parents commute to work, they drive to work, right? People commute to Los Alamos for work. They leave Santa Fe and they drive to Los Alamos. They work, then they commute home. Some people commute to Albuquerque. I used to have a friend who commuted from Albuquerque to Los Alamos every day. That's a long commute, you know? So that's the first property. You guys already know it. The second property that I'm going to talk about is called the associative property.
Wow. I think I learned that too.
Very important property. And this also works, let me think about this for a second. This also works for addition and multiplication.
Only?
Yes. Addition, well actually, let me think about that for a second. Associative property of addition. Yeah, I'm going to just say addition because you have to turn it into addition again or multiplication to make it work right. Multiplication. And I'm going to give you an example of what this looks like. Addition would be A plus B plus C is equal to A plus B plus C. The only thing is I'm going to do this.
Oh, is that? Oh, this one.
Oh, this one.
No, we're
Right,
just
yeah, this one. So people sometimes have trouble remembering this one. I actually find this one the easiest to remember. Or one of the easiest, and I'll tell you why in a minute.
Oh, wait, does that
I
mean
just want
like?
to be, I want to be sure you've written it down first. Go ahead, Hunter. What do you
Does that mean like you have like 2 plus 5 plus 6, and you have like the 2 and the 5 in parentheses, and then you could mix it all together and be like 6 plus 2 plus 5, and then it would all
Almost. You just mixed your commutative property and your associative property, right?
That's what usually happens. Everyone
Right.
starts mixing.
They start mixing them. Notice, when I wrote this first, I didn't put the parentheses first. Did you see me do that? I said A plus B plus C equals A plus B plus C. First of all, what do you notice about that?
Exactly the same.
They're exactly the same, right? Exactly the same. If they're exactly the same, what changed? The only thing that changed was the parentheses. So when you look at this word, what does it remind you of? What kind of word does it remind you of?
Association.
Association, right?
Associative.
Associative.
Look at associate.
Oh, wait, that's what the word is.
I just think when I see it, I think socialized, right? When you're associating with people, you're socializing, right?
Yes.
All right. So I have A. Here's A. Well, I need 2 people. Oh, no, I can't do that because we're filming. So here's A, here's B, and here's C, right? So right now, they're all standing in a row, A, B, and C, right? And B is holding his little cup of tea, right? He's holding his cup of tea, and he's talking to A. Hello, A, how are you? A's over here. Oh, very well, thank you so much, B. And then B says, very nice to talk to you. And that's where the parentheses are, around A and B. Poor little C. Oh, they're all by himself, not talking to anybody, feeling totally alone. Oh, so sad. B turns over. C, you're beautiful. Oh, C, I'd like to get to know you. Okay. Oh, thank you so much, B, but no thanks. But suddenly, poor A is not socializing, but B and C are socializing. They're having a great time. And then suddenly A, so that means this parentheses around B, and C, right?
It's always
And then
One always has to be
A
left out.
taps B on the shoulder. B does not move. He just merely turns his head. Hello, A, and suddenly we're back again. They're the same thing, right? It's just they're socializing. The parentheses are saying, okay, A and B are socializing right now. C's there. A, B, and C are still in the same order. Now B and C are socializing,
So
right?
can we just be like A plus B
And then plus C.
Right.
And
Or
then,
A plus,
and
or,
then B plus C plus A.
right. But you got to keep the A in the front.
Yeah.
Otherwise, you're doing both. You're
Oh,
doing
wait.
associative and commutative.
A plus B plus C.
Right, exactly. You got it.
I have a question.
Does that make sense? Yes.
Why can't you have a three-way conversation?
Oh, I'm sorry. That is not acceptable.
It's a law.
Okay, so
Three-way
in multiplication, you have the same thing. You have A, B, C is equal to A, B, C,
Or CBA.
right?
A, B, C.
But if you do CBA, then suddenly now you're mixing it. You're back to commutative property. Because you commuted, they've moved, right? The only thing that moves with associative is the parenthesis. It's the only thing to be true of associative property.
But you can't move the numbers then.
Well, you can, but then it's not just associative. Then it's suddenly also a mixture of commutative and associative. See what I'm saying? Right? I'm just trying to keep them separate for now so you can really understand that principle, that property. Okay? The last one.
I'm running out of space.
Oh, we'll just turn the page then, okay? Okay, so
Well, just turn your face. Yeah, solve it.
the last one is the one you are going to use. Well, actually, you're going to use all of these all the time. Distributive property. I should have done this one first so that I don't have to bend down. Okay, but I'm going to bend down. But distributive property, you will use this all the time. You use these two, but you don't notice it as much, right? It's more theory with these two. With this one, it's something you do in order to solve for x. You're going to be solving for x a lot, or y, or a, or m, or z, or whatever, right? You will need to know how to do the distributive property. And this is how I'd write it with letters. A times B plus C is equal to AB plus AC.
This is probably the most
A times, parentheses always means times. A times B plus C is equal to AB plus AC. Now, what that means is I am multiplying the A times each thing individually inside the parentheses. So, see what I mean? Can you see this okay, Domenica? When I do this, A times B, I'm putting a little arc there. Can you see that? Or am I in your way? Okay. And then here, A times C. So I'm going to go first thing A times B, plus A times C, A times C.
Oh, so it could be either. Oh.
So,
looks like an elephant.
so what's interesting about this, what's interesting about the distributive property, it looks like an elephant. That's pretty cool. I'm glad we're filming this one. That's an elephant. Thank you so much. Okay.
Elephant.
Did you make this?
So I want to show you something really cool. Watch this. Let's say A is 4, B is 6, and C is 5. Okay. Now, if you use PEMDAS, what would you do? PEMDAS, whatever. Okay, what would you do? You would do 6 plus 5 is what? 11. And then you do 4 times 11 is 44. Now, if distributive property really works, you should get the same answer. Let's try it. We have 4 times, there's my elephant again. This is so fun. That one's better though, but okay. But we got 4 times 6 plus, right? 4 times 5, 4 times 5. Let's see, what is 4 times 6? What? I'm sorry? 24 plus, what's 4 times 5? 20. What's 24 plus 20? 44. We got the same thing. Isn't that cool?
This would appear more if you had an exponent. I mean, not an exponent, a variable in it, like, because you can't add it.
Oh.
Maybe
Right.
you'll go into that when you go into the
Right.
term.
Most of the time when you see these, one of the numbers, one of the terms inside the parentheses will be a variable. So you'll have 4 parentheses x plus 5, right?
And then you
Instead
just
of
have 4x
6 plus 5.
plus.
Right.
20.
But you got to remember, x is a number. We just don't know what it is. So that means we should be able to, it should work with real numbers. So we just tried it. We just proved it. It works. Right? And am I going to have time
We
for
have
this?
1 minute.
Yes, come on.
Okay, we're going to do it really fast. Does that make sense? You guys understand that stuff? Those are the properties you have to know. Like terms. I'm just going to do this kind of quickly. But like terms, my definition for like terms is this. Like terms are terms, so write this down, are terms that have exactly the same variables. That have exactly the same variables. Okay? So a like term, let's say if I had 4x, a like term to 4x would be 6x. And that means if I added them together, what that means is I have x plus 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 x. How many x's do I have?
10x.
I have 10 x's. So the way I read it, I don't really, when I see 4x, I think 4 x's, right? I think of 4 x's, what did I say? 4 x's plus 6 x's is how many x's? It's 10 x's. So when you add, when you add like terms, you can add, what are these called again? The number in front of the variable is called the coefficient, right? Remember that? Coefficient. You got to know these terms. You add the coefficients and keep the variable. So that equals 10x, right? If I had 20 w and I subtract 10 w's, how many w's would I have? I would have 10 left, right? I'd have 10 w's. Now, what if I had this? What if I had 2? Give me like 1 more minute. Is that okay?
2.
Okay. What if you had 2ab plus 5ba? What would that equal?
780.
But are they like terms?
Yeah.
How do you know? They have the same variables. And look, commutative property says AB is the same as BA. So they're the same. So you just choose which one to write. I usually choose the one that's in alphabetical order. I'll put A first and then B. So I would say the answer is 7AB. And that is like terms. They're very simple.
Wait.
Okay.
What if
Question?
it's like 2ab plus 1 minus x plus a? Plus ab.
Okay, one last thing, really fast. If you had something like this, 2x plus 3y plus 4x plus 10y, you would add only the like terms. These two together would be 6x. These two together would be 13y.